Well, hello there. Dave Gaitros here, and we're still on our lecture on dynamic storage allocation. A couple things I want to do. Dynamic arrays in classes. This will be about dynamic arrays, which are very important. They're used a lot. So we're going to go back and review them a little bit. They're just really pointers, as is most everything inside a computer anyway. And you have two. You have a standard size array, which is fixed size, and you have dynamic arrays. Dynamic arrays are the ones that are really very, very useful. They're used quite a bit in computers because when we initially come up with the size of an array, a lot of times we don't know the amount of storage that we need. And what you don't want to do is you want to allocate the maximum because that's could be a real waste. Okay. Really, arrays stored in memory, they're just done sequentially, whether they're single or multidimensional, doesn't really matter. The array name itself always refers to the first one, which is index 0. And it's really an offset. Now, so for example, the two below, and let me make this a little bit larger here, and we'll actually go into slideshow from current slide, if you can see it. First one down there, int a with the brackets of 10 and the int asterisk p, they're really identical to the computer itself. So it really doesn't know the difference between the two of them. The previous examples where we use the type def, they're also identical. A and P are pointer variables, and they contain addresses. And notice that P is equal to A is legal. P now points to where A points to, but the next one, array pointer, is a constant pointer, and the next one is legal. And I don't know why you would do that anyway. More than a pointer, constant int asterisk is a type. You allocate the memory and it's fixed, and from that point on it cannot be changed. So if you specify the size of the array upon definition, like we did up there in the top, it can't be changed. Not only that, but you can't return it as a value to something. It must be dynamic. So it's not very flexible. Okay. There are array limitations. The must specify a size first, and you may not know that until the program runs, and that's why dynamic arrays are really good. It requires you to estimate the maximum size, which in some case would be a real waste of memory. Therefore, we have dynamic arrays which allow us to grow and shrink it. And what I'm going to do is I'm actually going to demonstrate that for you in a little bit of code that I have. Very simple to create it. We use the new operator. Example down below is we have a double pointer D where we assign a new allocation of 10 double floating point numbers to D. It goes out to the operating systems, gets that storage location, gives it to D, and we can grow it and shrink it. Dynamic arrays allocated on runtime, so it should be destroyed at runtime. It's either destroyed by us when we're done with it, or whenever we leave the program or module. Okay. Simply recall that whenever we do a new double floating point numbers, that to delete it we have to put the square brackets in front of it to say that it is an array. So it's many versions or many storage locations of that same type. Arrays type not allowed as return type as function, so a fixed array is not going to work. So example below is where it has int in the square brackets indicating that this is a fixed size array. That's not legal. You can only return arrays that are dynamically allocated. You can also perform addressing on array addresses, but you are limited. For instance, whenever I have the example here, a double floating point number, recall that a double floating point number is 64 bits or 2 words or 8 bytes. So whenever I say d plus 1 or d plus plus or d minus minus, it doesn't just add 1 to the address, it adds the size of the type. So in this particular case, it's going to add enough to get me to the next value. And this is just an example of that. There is no multiplication, division, or modulo that's allowed on it. You can add and you can subtract. You can even use the increment and decrement operators like below plus plus. But remember, it adds enough bytes to it to get you to the next location. So let's say an integer, it would have to add 4 to it. So if you say integer pointer plus 1, it's going to add 4 to that address to get you to the next integer. Okay. Multi-dimensional arrays are kind of interesting. We define them as it actually is just a sequence of arrays. It's just also a linear row of them, but they're created a little bit differently. You'll notice that here, I'll show you right here, we have, I'll actually show you that whenever I give you, it's actually a pointer to a pointer is what it actually accounts to. It's best that I actually do this as an example. And let me go here, and I'm going to reduce this and bring up C-line, and I'm going to write some code, which I have ready already, and I'm going to demonstrate dynamically allocated arrays rather than just regular arrays. And we got our basic program here. Return 0. Alright, now the first thing I want to do is I want to declare an array. So I'm going to declare array is int asterisk d array, and we'll say that's for a dynamic array. And then what I'm going to do is I'm going to allocate it some memory. D array is equal to new int, and I'm going to give it 100. So I'm going to give it 100 elements. Alright, so that's how you dynamically allocate elements to an array. Now let me show you how to pass it as a parameter. I'm going to go up in here, I'm going to write a routine called void clear array, and I'm going to pass it the array itself, which is an integer asterisk, I'll call it a, but I'm also going to pass it the size, constant int size. And now let me go down and write that array. Got to put it in the right place here. Hold on. X. There we go. So now let me go write that and show you what that looks like. So void clear array. Alright, int asterisk a, I'm passing in a pointer of an integer, and it's going to be an array, and I've got to tell it how big it is. Okay, so in the clear array, what I'm going to do is I'm going to say for int index equals 0, while index is less than size. I'm going to say index plus plus. And all I'm going to do is I'm going to say a index is equal to 0. Okay, and I'm going to go up here and I'm actually going to call it now. I'm going to say clear array, and I'm going to pass it the dynamic array and the number 100. Okay, good illustrations. Now a point about the syntax. It's not going to return a type. I'll show you how to return that in a minute. The int asterisk a means I'm returning it by reference, or I'm passing it by reference. A can either be just a pointer to an integer, or it can be the first address of an array element. There is a way to tell the size of an array. I'll show you how to do that in a later lecture, but we're telling it the maximum size, or the size we want it to work with, by passing in the second parameter. And we're going to zero it out. Let's go ahead and build this. Let's just convince ourselves that it compiles and that it runs without error. And yes, it does. Now, just to prove to myself that it does work, let me write another one exactly like it. A constant int size. I'm going to print it. Okay. I'm going to say print array, the array 100, and we'll go down here and write that routine. Void print array int asterisk a int size. Looks a lot like that one up there. In fact, I can actually go up here and copy it and paste it. That'll save me some time, won't it? But I wish I could do this back in the days when I was using punch cards. Okay. Okay. See out. I'm going to see out the A index, and I'm just going to put a space after it, and then a carriage return after that, so we can just see it come out. So let's convince ourselves it worked. We'll build it, and we will run it, and it looks all zeros. It looks pretty good to me. All right. Now then, let me write another one just to show you how to put things into it and pass it again. Again, this one looks a lot like the others. We'll say fill array int asterisk a constant int size. We're going to fill it up with numbers. Fill array d array 100. And then we're going to go down here and we're going to say void fill array int asterisk a constant int size, and all I'm going to do is, again, I'm going to copy this up here and put it down there, and I'm just going to give it the index of the value of the index it is. So it'll go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and fill array should print it out. So we should see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 go all the way across. Let's see if that works, and then we'll run it, and ta-da, there it is. And we'll just scroll over here and convince ourselves it goes all the way over to the right, and okay, I think it does all the way to 99. Great, wonderful. All right, now here's the fun part. Okay, we're going to make it larger. Okay, now to do that, I'm going to return it as a type, and this is a real interesting routine. I'm going to return an integer pointer. Okay, I'm going to say make larger, and this is an interesting thing to do. I'm going to pass it the array. I'm going to pass it the size of that it is right now, and I'm going to pass it the size that I want it to be. So what I'm going to do is I'm going to increase the size of the array and add more space to it. How's that done? This is really an interesting routine. This is kind of how it's done. I'll make larger. Okay. Okay, now then, the first thing I've got to do is I've got to declare a place to store this new array, because I can't use the existing address. I've got to keep it to copy the things from it to the new one. So I've got to create a new one. I've also got a problem too, that anything I create inside of here goes away once the routine goes away, unless I use the word static. Okay, if I use the word static, it stays there. So I say static integer asterisk. I'll say new array. Okay, and I'll say new array. Okay, is equal to new. Okay, int, and I'll give it size 2. That's the size I want it to be. I don't know what it is. I'll pass that in and tell it. All right, assuming that it's larger. Okay. And it would also be a good idea right here to check to make sure that size 2 is larger than size 1 if we're going to make it larger. That's just a safety thing to do, but I'll leave that up to you. Okay. Now the next thing I want to do is I can go ahead and clear the array. So I can say clear the array. I'll say new array, and I'll give it size 2. Okay. I'll clear the array, and now I want to copy it. I'm going to say for int index equals 0, while index is less than size 1. Okay, that's the size of the original one. Index plus plus. Then I want to say new array sub index is equal to new array, or the original array of index. Okay, so there it copies it over. Now once it's copied, all right, I don't need the original array. I can say delete A, so I get rid of it. Okay, so I've gotten rid of that. I've done all my housekeeping. So now I can return the new array. All right, so that should clean that up. All right, so here what I want to do is print the array and fill the array. And before I print it, I'm going to say make larger. But you'll notice I get a little error here. I'm going to leave the error there. I'm going to say A 100 200. All right. Right. But this doesn't do me any good. I've actually got to give that address to some, so I'm going to give it back to that one. So what it's going to do is it's going to go out and it's going to copy, create a new array, get that address, copy the contents of the old array into the new one, and then give that new address back to the original array and print it out. Let's run this. Okay, that looks pretty good. Now let's run it. And what we should see is we should see 0 through 99, and then the rest of them should be, oops, let me print that, 200. Build it and run it. Alright, now let's see it. There we go. Now from 99 on out, they're all zeros because it copied the first 100 in there. So that's how you actually make a two-dimensional array. One last thing I want to show you before I go is how you declare a dynamically allocated two-dimensional array. It's done like this: int asterisk asterisk td array. All right, and I'll just go ahead and show you. Say is equal to td array. Okay, that's how you declare it. And what you do is you say td array is equal to new int. And what I have to do is I have to say asterisk, and I have to give it the row size. Okay, row size we'll say is 100. Okay, and what it is, it's a pointer. Then what I have to do is I have to do a for loop for int row is equal to 0 while row is less than 100, row plus plus. And then what I have to do is I have to say td array, so row, okay, is equal to new int, and then give it another. So it's a 100 by 100 two-dimensional array. So what it is the row points to a series of columns. So it's a pointer to a pointer. That's reserved for another class, but that's actually how you do a two-dimensional array, and that's the way you would return it to you. You'd have to return it with two asterisks if you're going to return it back to a variable element. All right, practice this. This is how you do two-dimensional arrays. Very good little exercise. And now we're going to go on to classes.